Okay, so today we're going to be talking about inscribed angles. So our targets are 1, identify and describe inscribed angles. 2, explain why inscribed angles on a diameter are right angles. And 3, prove properties of angles for quadrilaterals inscribed in a circle. We're not doing like formal 2-column proofs. We're just kind of using what we know about inscribed angles to apply to properties of quadrilaterals inscribed in a circle. So let's first talk about what is an inscribed angle. What does that look like? So here are 3 examples of what inscribed angles look like. So notice that the angle is inscribed in a circle, of course, but the vertex is also on the circle right here. Okay, now remember, we have been working with central angles when we're looking at arc length and area sector. So be careful, central angles go to the center of the circle, but inscribed angles go to the actual edge of the circle. So the vertex is on the edge of the circle. So let's look at the relationship between what an inscribed angle is and the arc that it creates. So inscribed angles here. So if I'm looking at this picture up in the right, measure of angle B equals half the measure of AC. So this angle ABC, this angle right here, is half of the arc. So let's say that the arc is 100. The measure of this arc is 100 degrees. Then the measure of this angle right here at B is going to be 50 degrees. So the arc is double the angle, or the angle is half of the arc. So let's say my angle here is 30, then the arc AC is going to be 60. So the measure of an inscribed angle is half the measure of the intercepted arc. Okay, so I've got a couple examples here. So this angle right here, CBD, this 45-degree angle, the intercepted arc from C to D is going to be 90 degrees based on what we just set up here. So the arc is half of the angle. So if the angle is 45, then that means the arc is going to be 90. Okay. Now this one here, they give you the arc, so you got to find the angle. So this arc is 76 degrees, which means that the angle is going to be 38 degrees. It's going to be 38 degrees. Okay. Looking over here, it's like a little bit more complicated. You see more angles and things like that. So just if you need to draw, like kind of highlight, here is my angle, which means that this is my arc from P to N. Okay, so if my angle right here is 68, that means the arc is going to be doubled. So that means it's going to be, well, 68 times 2, or 68 and 68 is 136 degrees. So this arc right here from P to N is 136. Okay. Now let's look at this arc right here from L to P is 92 degrees, which means that, well, let me kind of highlight here. So L to P is 92 degrees, which means that this is the angle that we're looking for. So LNP is the angle that we're looking for. So if I got the arc, we want to cut it in half in order to find the angle. So the angle here is going to be half of 92 is 46 degrees. Okay. So that's basically inscribed angles. Now, if an angle inscribed in its semicircle is a right angle, so an angle inscribed in a semicircle is a right angle. Well, a semicircle is just a half of a circle. So from P to Q, that's a half a circle right here. So if I'm thinking here, remember, the measure of the arc is double the angle. So if I've got a half a circle Well, half a circle is 180 degrees. Okay, it's 180 degrees, which means that the angle right here has to be 90, because what's half of 180 degrees? 90 degrees. So that's only the case if it opens up to a half circle, or a semicircle is what they say, a semicircle. Then we have this inscribed angle will be a 90-degree angle, all right? So I've got a little example here that deals with a little bit of algebra. So this angle G opens up to a half circle. See this FJH? That's a diameter, so that means it cuts it right in half. So that means this right here, this arc from F to H, that's 180 degrees. That's a half a circle. So that means angle G is going to be 90 degrees. Okay, that's going to be 90 degrees. So now it's asking me to find the measure of angle F. So if I'm thinking, look at this, the shape is a triangle. So the angles inside of a triangle add up to 180 degrees. So I'm just going to type it out. So I've got 4x plus 2 plus 4x plus 2, that's angle F, plus 90, angle G, plus 9x minus 3, that's angle H right here. If I add all of those up together, it's going to equal 180 degrees because we have a triangle. So let's go ahead and combine some like terms. So I've got 4x plus 9x is 13x. Okay, 2 plus 90 is 92. 92 minus 3 is 89. Equals 180. It's positive 89, not negative 89. Okay, now I'm going to go ahead and subtract 89 for both sides of the equation. So 180 minus 89, that cancels out, is 91. Okay, so I'm going to bring down this 13x equals to 91. Divide both sides by 13. Divide by 13. X equals 7. 91 divided by 13 is 7. Okay, so I know what X is, but it says to find the measure of angle F, so that means I got to take 7. I got to plug it in here. So 4 times 7 plus 2. Okay, well, 4 times 7 is 28. 28 plus 2 is 30. Okay, so that's my answer, 30 degrees. That's the measure of angle F. All right, one more thing that I want to talk about. Opposite angles of a quadrilateral inscribed in a circle are supplementary. So remember, supplementary means add to 180. So that means the opposite sides of a quadrilateral, so like this 93 and this Z, the opposite, I'm sorry, not side, but angles, the opposite angles, so 93 and Z, those add up to 180 degrees. They add up to 180 degrees. So it should be pretty easy to find what Z is. To find Z, all I got to do is 180 minus 93, and we get 87 degrees. 87 degrees, okay? Now, X and Y, that's a little bit trickier to find, okay? Well, I know they both add up to 180. I know X plus Y add up to 180. Well, notice here, I've got some measures on the outside of the circle. So I've got the arcs. So I've got this arc here. I know this part is 58, and I know this part right here is 106. Well, that makes up this inscribed angle at X. So X is the inscribed angle, and it creates this intercepted arc of 58 and 106. So that means this whole arc, 58 plus 106, is 164 degrees. So from here all the way to here is 164 degrees. Now remember, at the beginning, I told you that inscribed angles are half the measure of the arc. Well, if the arc is 164, then that means x has to equal 82 degrees. Okay, now if x is 82, y and x have to add up to 180. So if x is 82, then y has to equal 98 degrees. Okay, that's all I've got for inscribed angles of a circle.